Okay, simplifying radicals with variables. Now remember what we said. If we don't see a little number here, sometimes they're cubed, and we have this list once again. These are my squares. These are the ones I'm used to. But then I've got perfect cubes, fours, fifths, and sixths. Okay, now here's what I have to do when I have radicals with variables. And by the way, this is a 2 here, so we know that it automatically is a 2 if we don't have anything. So it's the perfect square list. And what I do is I put my own square root here. And what I need to do is break this up, okay? So I have square root of 16. Square root of x to the power of 5, the square root of y to the power of 7. So let's look up 16. We simplify this like normal. 16 is on the list, okay? So I cross this out and just put what it equals. It equals 4. Now, since that's on the list, okay, it's on the list, so 4 goes, I'm going to put a little note that 4 goes outside, okay? That's what happens when it's on the list. So 4 is going outside. Now, here's what you do with x's, okay? You've got x to the 5th power, so I'm going to write out quickly 5x's. Now, I circled 2 of them at a time, okay? Because for every 2 x's I have, then the square root cancels. And then I put a root over that x right there, the remaining x. That can't go in a circle because it doesn't have a pair. How many pairs did you make? How many circles? 1, 2. So don't put 2, it's x to the 2nd. Then how many x's did you have that were isolated? You had an x, so that goes inside. Okay, y to the 7th, there's going to be 7 y's. Now remember, every time there's 2, the root cancels out, and that just gives me a y. So there's 1 left here. So how many full groups do you have? You have 3. So outside you put y to the 3rd power. Then you have a y inside, and that's the answer. Okay, now don't go working on the problems because you need to see what to do when you have 3s and 4s outside. Okay, now again here, and we did this last year in Algebra 1, this part here, we did not do cube roots. So you got square root 20. By the way, it's a 2, okay? I like to put that there so I know what list I'm looking at. 2x to the 11th, 2y to the 5th. Okay, so we got 20, okay? So again, you're still on the same list. Now 20 is not on the list, so I need to start dividing 20 here. Probably start at 16. Fail. Fail. Success. So I make 2 roots. They're both square roots, and I put the 4 and the 5. Now get rid of that square root of 4 and replace it with its integer equal of 2. Okay, so I put 2. Okay, now that 2 is going outside, and the 5 is going inside. X to the 11th. What do you want me to write 11 x's? Well, if you can do it in your head, you don't have to, but if you can't, you better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 at a time because it's a square root. And then this one stays in it. So I got 1, 2, 3, 4, 5 full pairs. So that's x to the 5th. There'd be an x. Now again, because that's x second, but there's a square root. Square root of x second means you have an x. It's like you free up an x. So you free up 1, 2, 3, 4, 5 x's. Y to the 5th. 2 at a time. Oops, sorry. So that's 2 full groups, y to the 2nd with a y left over. Boom. Okay, now you're dealing with cube roots. So now you put a little 3 there, and you got to move to your cube list. So I have cubed root of 108. the cubed root of x to the power of 7, the cubed root of y to the power of 9, and the cubed root of z to the power of 13. Okay, now that that's been done, we need to look at our cube list. Now 108, is that one of the numbers on here? No, it is not. It would be somewhere in here. So I divide 108 by 64. Fail. 108 by 27. Success. Okay. So I put 3, 3. So 27 and 4. In that order too, because you always want to get rid of the first one because that's the one that has the equal of the integer of 3. So 3's out, 4's in. Okay, now the game changes. It's a game changer when you have a 3. It's not hard, but you got to recognize it. Now you're not going to put them like the 2. You're going to group them into 3s. And this one has it. Now you got 2 groups, x to the second, with 1 left. 3, 4, 5, 6, 7, 8, 9. Group them by 3s, and there are none left. There's just 3 full groups. So you're not going to have a y inside. All the y's are free outside. And then z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 1 left. So we know a z is going inside, and sorry, I didn't leave a lot of room. 1, 2, 3, 4. Just put a z to the 4th right there. Okay. All right, now it's a 4th root. So I've got the 4th root of 96. When you start the problem, you got to assume some stuff comes out, others is left in. 4th root of x to the 10th, 4th root of y to the 7th, and then the 4th root of z to the 4th. Okay. Okay, so now I'm not on squares and cubes. I need to be on my force list, and 96 falls not on here. So I'd start with 96 divided by 81, which does not work. 96 divided by 16, booyah. So I put 16 and 6, okay? And they're both 4s. Now this is not 4. You get rid of this, but it's a 4th root, and that equals 2. Okay? So 2's out. Give yourself a little more room than I put the 2 way out here and put the 6 here, because you got variables to fill in the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to circle them in groups of 4. Those stay in the radical. So you're going to have x second in the radical, and then x to the second outside. Okay, y to the 7th. 1, 2, 3, 4, 5, 6, 7 by the 4s. Okay, you can't get 4, so you'll have y to the 3rd inside, and then y to the 1st. You can put y to the 1st or just y. It doesn't matter. Z to the 4th. 1, 2, 3, 4. Okay, and just one. You don't have any z's left. Just a z outside, okay, because there's one group. You can put 1 if you want. Okay, now I got a couple ones on the back side I will be going over. Okay, I need to change something here. I want to switch that 320 to just a 20. Okay, so 3. So you got cubed root 20. Cubed root x6, cubed root y to the 9th, cubed root z to the 2nd. Okay, so 20. Okay, now you're on our cubes. So this is 4th, 5th, and 6th. I need to go to my cubes. So 20, start dividing. You'd start with 8. And if it doesn't divide by 8, you're not going to do 1. Okay? So I wasn't able to divide this by anything. It wasn't on the list. That goes inside then, okay? It's not like the first one where 16's on the list and you have 4 and you put it outside, okay? When you can't find anything to divide by, you put it on the inside. Okay, x6, 1, 2, 3, 4, 5, 6 by the 3. You don't have any x's left, but there's 2 x's outside because there's 2 bubbles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's 3 full groupings. There's no y's left over. Now z to the second is 2 z's. You can't get a full group out of that, so you have no circles. You just put the root and z to the seconds here. You're not going to have any z's here. Okay, and then fourth root of 80, fourth root x to the 12th, fourth root y to the 3rd, fourth root z to the 10th. Okay, so my fourths. Okay, so 80. Well, 80 falls in between here. It's either going to divide by 16 or we're going to keep it inside. Okay. So 80 divided by 16. Okay, that worked. So I make 2 roots, both with 4. They're not fourth powers, they're fourth roots. So fourth power goes up to the right. So 16 and 5. Okay, so we get rid of that, and that's not 4, that's 2. So we are going to be placing 2 out with 5 in. And then x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can't do it in your head. You better write them out. You can't get lazy. So 1, 2, 3. So that's 3 groupings with none left. Okay. Y to the 3rd. 1, 2, 3. Now you got to group them by the 4, and if you can't do anything, then y to the 3rd stays inside the root. Z to the 10, the radical, I should say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Group them by the 4s. Okay, there's 2 full groups with 2 left. Boom.